Okay, so the binomial coefficient is the first thing we're going to start with for this section. So this is your formula for the binomial coefficient. You have this n over r in parentheses, and then you've got n with an exclamation point. That n with an exclamation point means factorial. Okay, and what factorial means is it's going to be multiplying a number in descending power until you get to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. Okay, so 10 factorial would be 10, 9, 8, 7, 6, etc., etc., etc. Okay, so that's what factorial is. So the formula here for a binomial coefficient is n factorial over r factorial, n minus r factorial. So if I look at example 1 here, I've got evaluate 6, 2 binomial coefficient. The n in this case is 6, and the r is 2. So I've got 6 factorial over 2 factorial, and then 6 minus 2 factorial. Working that out, okay, let's see, this gives me a 6 factorial, so 6 times 5, 4, 3, 2, 1. Over 2 factorial is 2 times 1, and then 6 minus 2 is 4, so that would be 4 factorial, 4, 3, 2, and 1. And then as you can see in here, these numbers, these 4s cancel each other out, the 3s cancel out, the 2s cancel out, and the 1s cancel out. So that gives us 6 times 5 is 30, 2 times 1 is 2, 30 divided by 2 is 15. Okay, now that's the long way to do it. This is also called the combination formula. Okay, so the combination formula is NCR. So it's N, so a number, choose a certain number. So if I said for NCR for 6C2, this is 6 out of 6 elements. I want to choose a combination of 2 elements. You can put this in your calculator. So if I pull up my calculator, I've got a little projector here for calculator. If I want to put this in, I go 6, and then I'm going to go over to the button that says math, and then I'm going to go to PRB for probability. So if I just scroll to the left, I should get that. The third one down, NCR, hit enter, and then 2. And then we should get that there. So your calculator will do this for you. Okay, so if we take example 3 here, 11 and 4, and we want to put that in our calculator, we would have 11 choose 4. So again, in my calculator, I would go 11, math, PRB, NCR, 4. So that gives us 330. So that's a lot easier than working out the formula. And I'm fine if you guys use your calculator. And if you're doing a problem on a quiz or something like that, and you just want to type that, then I know you did your, or write that out, I know you did your calculator, or you can do it the long way if you'd like as well. So let's just do a couple more examples. Here we go. So I've got 8C0. So if I look at this one, I want to do this one the long way actually. So this is 8 factorial. Our R is 0, so 0 factorial, and then 8 minus 0 factorial. So that actually gives us 8 factorial over 0 factorial, 8 factorial. So these guys cancel out. There's nothing up here. That's a 1 over 0 factorial. So 0 factorial, this is a math fact that we want. If we take that and we put that in our calculator, there's nothing to multiply down. But if I go 0 and then I hit the factorial button in my calculator, so if I do the same thing as if I were doing NCR, you notice the exclamation point is right there underneath it. So if I put that in as 0 factorial, I'm going to get 1. So that's a math fact that we want to recall. 0 factorial is going to equal 1. Okay, so this is 1 over 1. which then would just give us 1. Okay, so anytime I've got a 0 in the bottom there, this is just 1. All right, and then the next, let's see, the next problem, you've got 17C6. So I'm going to put that in my calculator. 17, then I'm going to go math, PRB, NCR, 6. I'm going to get 12,376. Okay, so that's our binomial coefficients. We're going to go on to the next page, and we're going to talk about a binomial expansion. So if I'm foiling something, I'm squaring it, or if I'm cubing it, I'm multiplying it 3 times. Those are all pretty easy to do, these first 4 here. But once I start getting into multiplying something out 4 and 5 times, then it starts to become a pain. Okay, so now we actually have a formula that we can use to deal with this. So let's just look at the pattern that we have for these problems. So if I look at my expansion, so I just kind of want you guys to look at the 4th and 5th expansions. Your first term is going to begin with x to that power. So if I look here, I'm beginning with an x to the 4th, and then I'm ending with a y to the 4th. And these are expanded to the 4th power. But when I'm expanding to the 5th power, I start with an x to the 5th, and I end with a y to the 5th. So my first term to my exponent, my second term to my exponent. Okay, all of your binomial expansions will follow that pattern. The variables are going to follow a pattern. So if I look at my exponents, okay, let's look at this. Look at the exponents just on the x. This goes 4, 3, 2, 1, and then nothing. So we're going to descend. Well, look here. There's nothing here for the y, and then this goes 1, 2, 3, 4. Okay, so you're following the pattern where your first term is going to descend, your second term is going to ascend. If I add my exponents, they're always going to equal my expansion number. So 5, okay, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, this is a 4 plus 1, 5, and then 5. So all of the exponents add to 5 on each term of this expansion. And then the coefficients are going to follow something called Pascal's triangle. So this is what Pascal's triangle is. So I'm going to start up here with number 1. That's going to be row 0 of Pascal's triangle. So Pascal's triangle is always going to expand with 1s on the outer banks. Okay. Your first 2 rows are going to look like this. Okay, then your second row, or your third row, sorry, is going to look like this. You're always going to have the 1s on the outside, but then you're going to take these 2 terms and you're going to add them together. Okay, so 1 plus 1 is 2, and you're going to put that there. And then you're going to keep expanding. So 1 plus 2, and you're going to put that answer there, is 3. 2 plus 1 is 3. And that's your next row. And then you're going to keep expanding. Put your 1s on the outside. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1, 4. And then we can keep going. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4, 10. 4 plus 1, 5, and so on. And then we can go 1 plus 5 is 6. 5 plus 10, 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. We'll do one more row. 1 plus 6 gives us 7. 6 plus 15, 21. 15 plus 20, 35. 20 plus 15, 35. 15 plus 6, 21. 6 plus 1, 7. Okay, then your rows of the triangle, this is row 0. This is row 1, 2, 3, 4, 5, 6, 7. So it's important to remember it always starts with row 0. And then when you expand, you're going to start, whoops, that was bad, to look on your outer corners here, that's going to tell you the row. If you look, I cannot draw on it sometimes. So 2, 3, 4, that's going to tell you what row you're at. But really what I would recommend doing, and we're going to pull something up here, is I would just go in Google and I would type in Pascal's triangle and go to images, and I'd find one that I like and use that. So I think this one is a good one. Gives you 11 rows here. So we're going to copy that because we're going to use that when we go through some problems. Okay, so now let's talk about using the binomial theorem to expand. So I have this problem here, x plus 5 to the 6th. There are two ways to do the binomial theorem. I'm going to show you both ways. Okay, so the first way we're going to do is following the actual formula for the binomial theorem. And then the second way, we're going to use Pascal's triangle to expand it. Okay, I like using Pascal's triangle better, but I'm going to show you both ways anyway. So let's go ahead and start with this expansion. So I have x plus 5 to the 5th. So x is going to be my first term, 5 is going to be my second term. So 5 is going to be that y here, okay? So we want to set this up. So we're going to set up the first term is just nothing in front, and you just have your first term to your expansion. So the first term is just going to be x to the 5th. Okay, then we're going to go n and 1. So my n is 5, or sorry, my n is 6 because that's the expansion, and I made this a 5. That should be a 6 because the expansion is to the 6th. So this should be a 6, and this is a 1. And then it's first term, and then it's n minus 1. So remember my n is going to be 6 here. So this is 6 minus 1. And then it's second term, which is 5. And then that's just not to anything. Okay, or we can say it's to the first. Okay, then you're going to go n2. So 6 and 2. And then you have your first term to the n, so 6 minus 2. And then your second term, 5, and then that's to the second power. So it's always to this bottom number here, 2, 2, 2. So then we're going to repeat that. You're going to have 6 and 3. Then your first term, x to the 6 minus 3, and then 5 to the 3rd. Okay, then our next term is going to be 6 and 4. And then you're going to have x to the 6 minus 4, and then 5 to the 4th. Okay, then you have 6 and 5. And that's going to be x to the 6 minus 5, 5 to the 5th. And then you're going to have 6 and 6. And that's going to be x to the 6 minus 6, and not y, sorry, 5 to the 6th. You're done when these equal each other. Okay, then you want to work that out and find these coefficients here. So I'm going to pull up the calculator. That's going to be 6C1 for our first one. So we're going to go 6 math PRB. I hit the wrong button. Hold on. So 6 math PRB number 3, 1. So that's going to give us 6. Okay, and I'm going to go through and do all of these. So 6C2. So that's going to give us 15. 6C3 is going to give us 20. 6C4 going to give us 15. 6C5 is going to give us 6. And then 6C6 is going to give us 1. Okay, then we are going to work. So this is x to the 6th. plus 6 times x to the 6 minus 1, so x to the 5th, times 5. So then I would multiply the coefficients, so I would go 6 times 5, and that would give me a 30 x to the 5th. So that's my second term. Okay, then here I would go x to the 6 minus 2, that would be x to the 4th, and then 5 squared is 25. So then I want to multiply the 15 and the 25. So that's going to give me 375 x to the 4th. Okay, then my next term, wait, I've got x to the... How did you get the... Go ahead.
How did you get the 6 over 2 in the parentheses? How did that equal 15?
So in the parentheses, I'm going n. So n is my 6 here. And then I'm following this pattern here. So the first term is really 6, 0 in the parentheses here. And then I'm going, it's always 6 in the top, and I'm just going up. So 0, 1, 2, 3, 4, 5, 6, until I get to the end. And that's part of the formula that we're following as we go through here. Does that answer your question?
Yes.
Okay. All right, and then the next problem, so we got 20 for 6, choose 3. So then that's going to be x to the 6 minus 3, so that's x cubed. And then 5 cubed is 125. So I'm going to do 20 times 125. And that's going to be 2,500 x cubed. Okay, then my next term, I've got 15. Then x to the 6 minus 4 is x squared. And then 5 to the 4th, I believe, is 625. That's 6 to the 4th. 5 to the 4th. Yeah, so 625. So then I'm going to go 15 times 625. So that's going to be 9,375 x squared. Okay, then here we've got x to the 6 minus 5, so that's just x to the 1st. 5 to the 5th is 3,125, and then I'm going to multiply that by 6. So this was 3,125. Let's all multiply, and 18,750 x. And then this is x to the 6 minus 6, so that's x to the 0, so that's just going away. And this is 1 times 5 to the 6, which is 15,625. Okay, so if we put everything together, here's what our final answer is going to be. We've got x to the 6th plus, let's see here, 30, x to the 5th plus 375 x to the 4th plus 2,500 x cubed plus 9,375 x squared plus 18,750x plus 15,625. So these are some long problems. They're not too bad, just the problems themselves are a little bit long.